Hello everyone, today we will talk about our project 3 macro model. My name is Jiahao and my partner is Jiahao. Our problem is first order high pass filter and we need to use only one OTA. And the OTA's negative input is connected to the output to form a feedback loop and also the input capacitor, which will form the high pass characteristics. And the positive input of the OTA will be grounded. Using this very simple structure, we will have a very straightforward analysis, which also has one assumption is that our output signal will not be saturated, and also the output of the OTA will form a tangent characteristics. And we can derive a very simple transfer function for that, but it will only this function has also an assumption that GM will not change. For very big signal, the GM will definitely change, and we derive this ODE from the KCL equation of the input capacitor node, and we use this ODE to making our model, which is how we write the code. This is our basic ODE. And the state variable in this code will be the Vout subtract the Vin. And then we will have our code. This is our first attempt, and we just modify the code given by the professor of a low-pass filter, and it's very easy. Although the input capacitor is determined by what we have chosen for our real circuit, and the copper, actually we use this this number is not very accurate. We need to use it depending on which board we are using. Basically, this is our ODE part, and the output will be the state variable, which is Vout minus Vin and plus Vin. This is our comparable black diagram. It's actually the same diagram that we showed before, and this DC input, we use the DC input to input as a ground, actually 0 voltage input. And the simulated results, we use this kind of very simple simulated setup. We will just monitor the input and output at the same time. We have chirps input, and in low frequency here, we can see a very clear envelope showing a high pass characteristics and also a very constant envelope for very high frequency. The step response is also very ideal for this high pass filter. It will be a differentiator characteristic. However, we cannot get measure results, no readable measure results, as we think the problem lies in the output is not within the ramp ADC range. We have known well that the ramp ADC has an output range, and we use a linear signal here to detect this output range. It's between like 0.2 to 2. But this is for the linear signal. We cannot just get any output using like the step response, a square wave or a sine wave. So we use like a very low frequency signal and use the measure voltage, and it is what we can see because this signal can be very low, much lower than our cutoff frequency. So this is why we cannot get a measured results. I still want to talking about the error of the motor. When the problem of the error of the motor is when the circuit is being saturated, which means it will move very close to the ground and very close to VDD. And this situation, we need to just have more measured results and take it into consideration in future models. Thank you.